Okay, let's start using logarithms for solving some problems. My favorite, finance. Everybody wants to make $100,000, but they'll say, oh, I only have $100 to put away. My question is, how many of these $100 payments, okay, do you have to make at a certain interest rate in your bank until you make $100,000? Okay, well, let's figure that out. Well, here's the question. First things first, if you're going to make an investment, usually they compound it monthly, and, well, you're going to make a certain amount of interest. In this case, it's 6%, which is way higher than most interest rates that you get in a bank right now. I think the interest rates are somewhere between 1 and 2%. They really are pretty lousy. So you'll be doing this for a long time if you're only going to put in $100. But here's a nice formula, and this formula has to be given to you on a formula sheet. You're never going to be asked to generate this formula because it's a pretty complicated one. So we got a pretty challenging question ahead of us here. What you're trying to find, that small little exponent n right there, that's the puppy. Okay, so let's start plunking in some numbers and let's have a real good time using our log laws. Well, FV, of course, stands for future value. Well, you know what your future value is here of your investment right now. You know it to be $100,000. So let's put that down. There's your $100,000. There we go. Your R works out to be, well, surprisingly enough, your R works out to be the $100 that you're going to put in a month. Right there. Boom. $100. Okay. The next thing here is, okay, bracket. All right. 1 plus the interest rate. Now, here's the thing. Here's the real big deal. You're told that you're at 6% annual. That means per year, but you're figuring it out monthly. So my question is, what is the interest rate per month? And the interest rate per month, surprisingly, is 6% for the year divided by 12 months. Oh my goodness. So if you think about this, this is 0.5% per month. It doesn't seem like a lot, but remember, this is compound interest, so it's kind of the snowball effect. It gets bigger and bigger each single month. So 0.5% is 0.5%, but as a decimal is 0.005. That makes it even smaller. Oh my goodness. Oh well, let's put it in there. Let's see what we get. Let me clean it up a bit here so we can have some room. Okay, so we know it's 0.005. Let's put it in. 0.005. Now, there's this to the exponent of n minus 1, close that bracket, over, there's that interest rate again that you have to put it over. And remember, that interest rate is still 6% compounded monthly, which is that 0.005 again. Oh my goodness, this looks like an absolute nightmare to solve. Well, surprisingly enough, no, it's not. One of the coolest things you can do is never give up on that which you've learned in grade 4. Okay? Cross multiply. Woohoo! So, you're going to take 100,000, you're going to multiply it by 0.005, and if you want, put it in your calculator. Okay, got my calculator right here. Clear this. 100,000. Okay, there it is. Times 0.005. Enter, and it gives you a pretty number of 500. Oh, well, that's not so bad. This gives you 500 equals 100. Look at this. Now you can add this together. Well, that's not so bad. This is 1.005 to the power of n. Subtract 1. Well, that's not such a bad looking equation all of a sudden. Okay, let's keep on going then. How can you solve this now? Remember, this is times. So, of course, divide by 100. Divide by 100. Oh, boy. That gives you 5 equals to 1.005 to the n minus 1. Gee, that doesn't seem tough at all now. Holy smokes. All right. Add 1 to both sides. That cancels, leaving you with 6 equals 1.005 to the n. Now, the problem is trying to solve this. Well, actually, it's not that bad because now you know logs. All you have to do is log this side and log that side. And remember, the log laws tell you that you can take this exponent and move it here. So now you have log of 6 equals to n log of 1.005, and check it out. All you have to do now is divide both sides by log of 1.005, divide by log of 1.005. That cancels with this, leaving you n. So n equals to, let's bring up our calculator here. Clear it, log of 6, perfect. Put the bracket, divided by the log of 1.005. There it is, bracket, and hit enter. And look at this. You're going to have to do 359.247 payments. 359.247 payments of $100. Okay, so this is going to take you in excess of about 25 years to do, by the way. Okay, you're going to need to do that many payments in order to get $100,000. I'm kind of curious. Well, wait a second. Let's just clean up this question, and then I'll tell you what I'm curious about. So you're going to make 359 payments, and your last payment, which is plus one more payment, which is going to be a lot less money. It's not going to be $100 to get you a $100,000. But I'm curious. So in a sense, you're going to do 360 payments. How many years is that? Let's bring up that calculator. 360 payments, you're doing monthly, divided by 12, works out to be somewhere in the neighborhood of 30 years. 30 years at 6% interest, then you're finally going to get about $100,000, which means if you're 18 now for 30 years, by the time you're 48, and you hope that it's 6% interest, by the time you're 48, you should have $100,000. That's a pretty good chunk of change.